Welcome to the course MCDM techniques using R. So, in previous lecture we started our discussion on fuzzy sets. So, let us do a quick recap of what we have discussed so far. So, we talked about fuzzy set theory and how it has been used in combination with MCDM techniques quite frequently, and what is the main idea behind usage of fuzzy set theory and development of fuzzy set theory. So, this was mainly to deal with uncertainty in the decision problems. So, this particular aspect we talked about, that there could be subjective preferences which might lead to impreciseness or uncertainty in the human decision process, and the way the preferences or responses are given by decision makers. So, fuzzy set theory has certain advantages using which we can handle some of these problems. So, we talked about that how it has been proposed by Jada in 65 and then another development along with Bellman in 70. We talked about the role of fuzzy sets and fuzzy logic in the modeling sense. So, that part also was covered. We talked about how fuzzy set is an extension of the conventional sets, and how they are different. There in the conventional set theory we require a characteristic function for mapping. Here in fuzzy sets we require a membership function, right. So, all these aspects were talked about. We talked about crisp set and how fuzzy set is different because it allows the partial membership. So, there is something of continuum of grades or degrees of membership. So, these aspects related to fuzzy set were discussed. Then we also talked about how to define a fuzzy set. So, we talked about that A tilde can be defined in curly braces as x comma mu a in parenthesis x, where mu a is the membership function which takes values from the capital X and maps them into a 0 to 1 range. So, this is the membership function, and where the value of this membership function mu a x comes out to be 0, then x does not belong to A tilde. If it is 1, then x completely belongs to A tilde. If the value lies between 0 and 1, then partially belongs to A tilde. So, we also discussed how the fuzzy set is defined. Then further we talked about the linguistic variable, and for example, we discussed age as an example and said that linguistic terms like young, not young, very young and not very young, some of these kind of terms are actually used to express the preferences by decision makers, and which can be then expressed using fuzzy numbers. We talked about the concept of linguistic variables and its importance and the fields where it has been applied. So, artificial intelligence, information retrieval, human decision processes. So, all these fields it has been applied. Then we move to another concept that is fuzzy numbers. So, we talked about how fuzzy numbers are defined. A fuzzy number is a fuzzy set having satisfying two properties, normality and convexity. So, you can see that this so normality is about having a least upper bound value as 1, so at least in a sense one element belonging to the set. Similarly, convexity is where all the elements they can be expressed in the using fuzzy numbers. If that is the case for all the elements of X, the decision matrix can be expressed in that form, then that is the convexity property that is satisfied. Then how different fuzzy numbers, different forms of fuzzy numbers can be used. So, depending on the decision problem and the overall context, trapezoidal fuzzy numbers, triangular fuzzy numbers have been proposed, however more popular being the triangular fuzzy numbers. So, all these aspects we talked about. We talked about TFNs as a triplet LMU. We also discussed this particular graphic to explain a TFN. Right. We also talked about this membership function mu x, as you can see in the slide, and how different values are being taken by the membership function as per the membership function. So, all this aspect we talked about. Then we stopped at this point where we were about to discuss the algebraic operations with fuzzy numbers. Now, having understood how to define fuzzy numbers, let us discuss the algebraic operations. So, let us assume we have been given these two triangular fuzzy numbers p tilde which is defined using L1, M1 and U1, and q tilde which is defined using L2, M2 and U2. So, given these two triangular fuzzy numbers, how the fuzzy addition can be performed. So, that is the first algebraic operation that we are going to talk about. So, addition of two triangular fuzzy numbers can be given like this. So, p tilde plus q tilde can be given as L1 plus L2 as the first parameter, M1 plus M2 as the first parameter, and U1 plus U2 as the third parameter, given that L1 and L2 both are greater than or equal to 0. Then this fuzzy addition is justified. Similarly, we can move to another algebraic operation with fuzzy number, that is about multiplication of two triangular fuzzy numbers. So, p tilde multiplied with q tilde can be given as multiplication of L1 and L2, second parameter being multiplication of M1 and M2, and then the third parameter being multiplication of U1 and U2, where L1 and L2 both are given as greater than or equal to 0. So, this is how multiplication fuzzy multiplication can be defined. Similarly, subtraction of two triangular fuzzy numbers can also be defined. So, here p tilde minus q tilde can be defined as first parameter being L1 minus L2, second one will become M1 minus M2, third one will become U1 minus U2, where L1 and L2 both are greater than 0. So, these three algebraic operation, addition, multiplication and subtraction, rather fuzzy addition, fuzzy multiplication and fuzzy subtraction. So, this is how they can be performed, quite similar to the way we do it in the conventional theories. Now, division of two triangular fuzzy numbers, similarly p tilde divided by q tilde can be given by first parameter can be given by L1 divided by L2, M1 divided by M2 and U1 divided by U2, where L1 and L2 all three are greater than 0. So, in this fashion division can also be defined. Now, let us talk about inverse of a triangular fuzzy number. So, if we are considering p tilde as the triangular fuzzy number for inverse operation, then p tilde minus 1 for inverse is going to be equal to first parameter will become 1 divided by U1. You see, instead of L1, now U1 is being used, right, because we are taking inverse 1 divided by U1, then 1 divided by M1, then 1 divided by L1. You can also understand from the point of view that L1 is less than M1 and M1 is less than U1. So, therefore, once you do inverse, it is the 1 divided by U1 which is going to be having the which is going to be the smallest value, followed by 1 divided by M1, followed by 1 divided by L1. So, therefore, the parameters will be like this, right, because for p tilde inverse 1 divided by U1 is supposed to be the smallest possible value. So, therefore, it has to be 1 divided by U1 because that is going to be also the smallest possible value. So, from that point of view also you can understand why this. So, this has to be greater than or equal to 0. So, this is the inverse. And then let us talk about multiplication of triangular fuzzy number by a constant k. So, any constant k, it can be multiplied by multiplied with the triangular fuzzy number p tilde. So, k multiplied with p tilde can be given as like this, first parameter k into L1, second one k into M1 and third one k into U1, where L1 is greater than or equal to 0 and k1 is also greater than or equal to 0. So, these are some of the algebraic operations, some of the which can be performed for fuzzy numbers. So, another operation which is about division of a triangular fuzzy number by a constant k. So, here p tilde divided by this constant k can be expressed as L1 divided by k, M1 divided by k, and U1 divided by k. So, these are the important algebraic operations that can be performed with fuzzy numbers. So, with this we have we have covered the basic background that is required for fuzzy sets, and with this understanding we can see how fuzzy sets can be used in combination with other MCDM techniques and decision making problems, multi criteria decision making problems can be solved. So, now we will move to the application of this method, fuzzy sets method, in combination with AHP, that is analytic hierarchy process. So, we will move to our discussion on that part, that is fuzzy AHP. So, let us move forward. So, let us talk about fuzzy AHP. So, fuzzy sets they have been used in combination with AHP by quite this combination is quite popular and have been used by a number of research studies and and other executive reports. So, the purpose of traditional AHP as we already understand is to capture the expert knowledge in the overall decision making process. So, the AHP provides us a method that can be used to capture the expert's knowledge. However, there are certain criticism of AHP which are in line with why we are going to use fuzzy sets in combination with AHP. So, we look at some of these criticism of fuzzy AHP. This AHP, traditional AHP, some of the criticism of traditional AHP still cannot really reflect the human thinking style. It uses an exact value to express the decision maker's opinion in a comparison of alternatives. So, these are some of the criticism of traditional AHP, and that is why we have this we are going to discuss the fuzzy AHP. Then use of unbalanced scale of judgments, inability to adequately handle the inherent uncertainty and impreciseness in the pairwise comparison process. So, these are some of the criticism which, if you look at the kind of criticism that they are, fuzzy AHP can be used to actually handle most of them. So, now let us start our discussion on fuzzy AHP. So, as we have talked about while our discussion on fuzzy sets is that sometimes it is very difficult for decision makers to give exact comparison, exact preferences in a quantitative fashion, right. So, to overcome that scenario fuzzy AHP it takes into account that it is sometimes it might be more accurate to give interval judgments rather than the fixed value judgments or exact judgment. Sometimes it might be more easier and more accurate as well to give interval judgments. So, as mentioned in the slide, typical difficulty to express preference explicitly due to the fuzzy nature of the comparison process. So, the way comparison might be being performed between two objects or elements that might be difficult. So, the fixed values might be very difficult to specify. So, therefore, interval judgments can actually be used. Various approaches with respect to for AHP, for fuzzy AHP have been used. For example, fuzzy ratios using triangular fuzzy numbers, trapezoidal fuzzy numbers, and the extent analysis method using triangular fuzzy numbers, also referred as extent fuzzy AHP. So, this extent fuzzy AHP, the extent analysis method using triangular fuzzy numbers is the most popular one. So, in our discussion now onwards, we are going to talk about external fuzzy AHP. So, if we look at the we try to understand what happens in extent fuzzy AHP. So we will also try to understand and compare it with what we have already discussed in some of the starting lectures in traditional AHP. So we will while we are discussing extend fuzzy AHP, we will also talk about the steps that are required to execute the traditional AHP. So let us start our discussion on extend fuzzy AHP. So linguistic variables, as we have talked about in the previous lecture on fuzzy sets, that linguistic variables are used to express the comparative judgments in fuzzy AHP and extend fuzzy AHP as well. So now these linguistic variables, so just like in the previous lecture we talked about, we had given the example of age where we said young, not very young, right, not young. So those are the kind of linguistic variables, linguistic values that can be used by decision makers to express their preferences. So and to in case of AHP, to perform the pairwise comparisons, to indicate their pairwise comparisons. So weights of criteria and ratings of alternatives, they can actually be indicated in that sense. They can actually be indicated in that sense using these linguistic values, linguistic variables. So there in the traditional AHP, when we take preferences from decision maker, whether for the pairwise comparisons of criteria with respect to the given goal, or pairwise comparisons among alternatives with respect to a particular criterion. So that was the decision makers in the traditional AHP were supposed to specify exact values, supposed to give fixed value judgments. So we used to get a number of comparison matrices there in traditional AHP. So one comparison matrix was about the a pairwise comparison among criteria, and then the other comparison matrices were about the pairwise comparisons among the between the alternatives with respect to different criteria that could be there. So a number of comparison matrices were generated there in traditional AHP. Now that process under extend fuzzy AHP is to be performed using linguistic variables, right. So therefore the decision makers would be making those pairwise comparisons using linguistic terms, just like the example that we have given, like age, we talked about that not young, young, not very young kind of terms can actually be used to perform the pairwise comparisons. Why this is being done? Because we are assuming that we are operating in a fuzzy environment where it is difficult for decision makers to give exact comparisons, to give so rather we would like them to specify like them to give the interval judgments rather than fixed value judgments. Now once these pairwise comparisons have been taken for extend fuzzy AHP from the decision makers, then we can use TFNs to specify these linguistic values, right. So these TFNs, once we have taken, then once we have converted the linguistic values to TFNs, then we can talk about, then we can move ahead with other steps. So steps are quite similar to traditional AHP. However, the mathematics, the underlying mathematics is going to be different. Now we are going to be using fuzzy algebraic operations, fuzzy addition, subtraction, multiplication and inverse and other operations. So therefore the kind of steps and the kind of mathematics that is going to be required, we are going to talk about some important steps that we will have to perform. So focus on that. We are supposed to compute a number of comparison matrices. So we have a number of comparison matrices, pairwise comparisons are there using linguistic variables and then TFNs. So that is there with that assumption. Now once that is there, so one comparison matrix would be for criteria, then others one would be for alternatives. So, we are taking whether it is for the criteria comparison matrix or for the alternative comparison matrices, we are taking them as object. So, this is we are defining as an object set capital X, the elements being x 1 x I up to x n. This is similar to n alternatives in traditional AHP, that for that comparison matrix for alternatives. And then we are taking a goal set, that is capital G, which is G 1 G j to G m, similar to M criteria in traditional AHP, right. However, we are talking about these object set, we are talking about these object set and goal set as in a more general sense, because one comparison matrix is about criteria and the other comparison matrices are about alternatives. So, to understand the underlying mathematics and the steps that are required to be implemented in extant fuzzy AHP, we are using these notations, which are different from what we have used in the lecture of AHP and in other lectures as well. So, we have object set and elements are there, right, and these object sets are have been compared with respect to goal set. So, there could be a number of elements in the goal set. So, these comparison values are available with us. So, with this we will move forward and talk about the steps. So, one thing is that extent analysis is to be performed on each object x I with respect to goal g j. So, this is there. So, for a object x I, extent analysis value would be obtained with respect to goal g j, and it is expressed using following notation. So, capital M I j, I is indicating the object and j is indicating the goal here. So, I can be from 1 to n, there are n objects, and j can be from 1 to m, there are m goals. So, these extent analysis values have been obtained. So, what these extent analysis values are? So, they are triangular fuzzy numbers. So, these fuzzy numbers we have. So, what we talked about the comparison matrices and having completed the having taken the responses from decision makers using linguistic terms, and then converting them into triangular fuzzy numbers. So, the values that we obtained is what we are referring as the extent analysis values here, and this capital M these and I j, I for object and j for the goal. This is what how we are denoting these values. Now, subsequent steps that we are going to use is they are going to use these values. So, let us move forward. So, in the step number 1, we are supposed to compute the value of fuzzy syntactic extent. So, we have already computed the extent analysis values, that is M, capital M's. Now, we are going to compute this fuzzy syntactic extent values that is capital S for each of the object, that is why you are seeing S I. So, I is for object, there are n objects from 1 to n. So, the values of these extent analysis values, the capital M's are going to be used to compute these syntactic values, S values, and these S values are going to be later on used in the subsequent steps. So, let us see what the expression is about. So, capital S I, this can be computed using this summation j is equal to 1 to m, where m is the number of goal number of goal elements. So, this summation is over that. Then we have these values m I j, and this is multiplied by another expression here. So, this is one expression that we have is this one, and then another one is this one. So, you see this this expression, we are supposed to take the inverse of it. So, this is again summation over 1 to n, that is for n objects, right, and then summation over j is equal to 1 to m, that is for m goals, and these extent analysis values m I j. So, after computing this inverse and then multiplication with this expression. So, this will give us the synthetic extent values. So, now that we are already familiar with the fuzzy algebraic operations. So, how this is going to be computed, because all these numbers are going to be TFNs. So, if we look at this first this expression. So, it can be computed like this. So, 3 parameter, first parameter corresponding to L is going to become summation of j equal to 1 to m L I j, and then the second parameter is going to become summation of j equal to 1 to m m I j. So, this summation is over m goals. So, these s values that we are computing is for each object, and then a third parameter is summation j equal to 1 to m u I j. So, with this the first first part of the expression would be computed, and then the second part, the inverse part of the expression can be computed like this. So, fuzzy inverse of algebraic operation we have already talked about, right. So, this is going to be, if we use the same formula that we have discussed in this lecture. So, if we use this, then this would be the expression. First 1 divided by u related component here. So, these summation would come as is. So, first summation in the denominator is going to be summation over I is equal to 1 to n, then summation over j is equal to 1 to m, and then u I j. And the second parameter is on m, and then the third parameter is on L. So, the algebraic part, how this is being expressed, we have already discussed. So, with all these summation also, it is going to be expressed in the similar fashion, because as you remember, the fuzzy addition and fuzzy multiplication also we are familiar with. So, therefore, the this expression can be extended in this fashion, given our understanding of fuzzy addition and fuzzy multiplication, and also the inverse fuzzy inverse that is being taken here. So, after the computation that are being done here, we will get the fuzzy synthetic extent values here, right, and so let us move forward. So, once this is done, then we move to step number 2, compute the degree of possibility of S2 being greater than or equal to S1. So, now again let us consider that we have two two synthetic values, fuzzy synthetic extent values S1 and S2 with respect to two objects, object 1 and object 2. Now, we were to compare them and what is going to be in that comparison, what is going to be the degree of possibility that S2 is going to be greater than or equal to S1. So, how do we compute that? So, considering S2 is L2, M2 and U2, and S1 is L1, M1 and U1. So, the degree of possibility between these two fuzzy synthetic extent is defined as this V S2 greater than or equal to S1. So, this value, so this possibility value is going to be given by this expression as you can see. So, we are taking a minimum of this membership function value for y and x, mu s2 y and mu s1 x, and this value is then taken, and then we take a sup of it given that given for all elements of y where it is greater than or equal to x, because you see it is corresponding to our computation of S2 being greater than S1. So, so with this we will get this value. The same computation can also be performed in another fashion. So, you can see here, so the same is being written here, another form is this. So, height of S1 intersection S2. So, that will also give the same value, and mu of mu S2 of this D, this will give the same value, where mu S2 of D is defined like this: 1 if M2 is greater than or equal to M1, 0 if L1 is greater than U2, and otherwise L1 minus U2 divided by this expression m2 minus u2 in parenthesis, then minus, then in parenthesis m1 minus L1. So, this is the membership function for S2. So, it will convert into this, and it will change into this, and the values can be computed from here. So, what we will get is the degree of possibility between two fuzzy extent S2 being greater than S1, that value will get, where this d that we are using here, this is the ordinate of the highest intersection point d between mu S1 and mu S2. So, what do we mean by this? Whatever the mathematics that we are talking about, if we look at in the graphic sense, so we can look at this diagram here. So, you can see L1, M1 and U1, and because we are talking about fuzzy numbers, so right, there is going to be overlapping. So, this is the overlapped region here, and you can see L1, M1 and U1, and then L2, M2 and U2. Because M1 being the most promising value, but L1 and U1 being the small possible value and large possible value. Similarly, for the second fuzzy number, that is S2 as well. So, there is going to be this overlap. So, this intersection is going to be there. Then D is this point of intersection, and the the highest point of this intersection, and when we were referring to mu S2 D, this was actually this ordinate value. So, corresponding to this we will get some value here. So, that will give us the possibility, that will tell us about the possibility of this capital V S1 being greater than or equal to S2. So, this is what we will get. So, the mathematics that we talked about here can also be understood through this graphic. The steps that we are talking about right now, discussing right now, they would be more clear once we do an exercise in R, where we will see through an example each of these steps and the computation that we would be performing and what they mean. So, we will elaborate more on those computations, what they actually mean, more in the when we do an exercise in R studio in our environment. Right now, focus is to understand the kind of computations that are going to be performed under extent fuzzy AHP. So, the step number 3 that is to be performed is to compute the degree of possibility for a convex fuzzy number to be greater than k convex fuzzy number. If you see that if you see that all the steps that we have talked till now, they are about certain computations that are to be performed, and therefore, the discussion is a more in a generic sense. The discussion is on the mathematics part of it, how the mathematics, how the certain computations that are to be performed under extent fuzzy AHP, how these mathematics, how this underlying mathematics is expressed, and later on we will do in more perform these steps more in a application sense, more in a through an example. So, if we are to find out that a convex fuzzy number that is S, and whether what is the degree of possibility for it being greater than k convex fuzzy number. So, if we are supposed to compute this, then it can be written as this, and this it can be written as this. So, capital V of S greater than or equal to S1 and S greater than or equal to S2. So, if it is individually, if this is greater than with all other synthetic values, then overall we can say it is greater than all k convex fuzzy numbers. So, if we take the minimum of this this V being S greater than or equal to Si, where I could be 1 to k, then that would actually indicate the this degree of possibility. So, having understood these kind of mathematics that would be required in this extent fuzzy AHP, now let us understand the last part, which is the compute the vector the weight vector. So, we talked about different comparison matrices, and later on the weights are to be computed. So, here this W dash can be defined like this: D dash A1, D dash A2 and D dash AK and transpose of this. So, what is this D dash in small d dash AI? So, this is nothing but we are referring to previous steps computation, the minimum of V S I greater than S j. So, one synthetic value being greater than the other one. So, that is what we are referring to, and that is being used to define the W dash. You can see here one I is from 1 to k and j is from 1 to k, and I should not equal to j. So, this is like a comparison being performed. So, we are talking about the underlying mathematics behind a comparison between two elements. So, if we were to write the normalized vector form of this, it would become something like this. So, this W in this normalized form will become a non-fuzzy number calculated for each comparison matrix. So, we will get non-fuzzy numbers after doing this normalization. So, with this we have covered the mathematics part of the extent fuzzy AHP. So, at every steps we have talked about certain mathematics that would be performed. So, if we look at this we take the linguistic variables to gather the comparisons from the decision makers, and those linguistic values then are converted into TFNs, triangular fuzzy numbers. Now, once we have those matrices, then we are supposed to perform certain number of computation to find out the weights and then the global and all those things. Just like we did in traditional AHP, the priority calculation that we are supposed to do, priority derivation. So, similarly here for that to happen, given that we have the comparison matrices, what are the certain mathematics, certain computation that would be performed. So, we talked about that. We referred synthetic we talked about synthetic values, how they are going to be used to tell us about comparison between two, because there is going to be, because we are operating in fuzzy environment, there is going to be overlap, and how we can still indicate the whether a particular synthetic value is synthetic fuzzy number is going to be greater than the other one. And we talked about the degree of possibility, that capital V of one synthetic value being greater than the other one. Then we talked about this weight, which is directly coming from that based on that degree of possibility. So, from that these weights are going to be computed. Then once we have these weights, we can always go ahead and compute the do our further computations. So, all this will understand more clearly through an exercise in R environment. So, that we will do in the coming lecture. So, we conclude here. Thank you.